Hey guys, it's Chris, and today I'll be explaining the physics of basketball and how to apply it to improve our technique. Hopefully this video helps you, and ask any questions down in the comments. So the topic of this video is the forces acting on the ball. Mainly I'll talk about gravity, thrust, the Magnus force, drag, and buoyancy. Let me get started with gravity. As you know, simply aiming the ball to the basket will not work, as it will end up falling too short due to gravity. Gravity is a constant vertical force on the basketball in flight. Once it is in the air, gravity will accelerate the ball downwards by 9.8 meters per second squared, until the ball's vertical velocity is 0, and it falls back down. We can describe its magnitude by using Newton's second law, F equals mass times acceleration. If we substitute in a basketball's mass and gravitational acceleration, we get F equals 0.625 kilograms times 9.8 meters per second squared, which equals to 6.125 newtons. The drag force, or air resistance, is a relatively small force compared to gravity. It acts on the ball as it pushes through air molecules, so it opposes the ball's movement. It depends on air density, the ball's reference area, and its velocity, all of which are explained in this equation. In the equation, Fd is drag force, P is air density, U is air velocity relative to the ball, Cd is drag coefficient, which is related to the ball's geometry and skin friction, and A is the area of the ball that's colliding against most air molecules. Now the Magnus force is an interesting one to discuss. As the ball drags air around with its spin, the airflow on the top is greater than the airflow at the bottom. This causes a pressure difference where there are more air molecules colliding at the bottom than at the top, which in turn causes the ball to be pushed upwards. A great demonstration of this force is done in this video. Now this is a pretty extreme case because the ball will never travel at that speed and that far in a normal shot. But this isn't always negligible, for example in the case of half-court shots and long passes. Take for example this full-court shot attempt by Kevin Love, who is a great shooter, but has trouble with the ball curving because he doesn't take the Magnus force into account. This force acts upward on the ball and is caused by even the slightest difference between the air pressure on the top and at the bottom. Because there are more air molecules colliding at the bottom of the ball than the top, it will be pushed up. I was able to calculate buoyancy's magnitude using Archimedes' principle. The buoyant force acting on an object immersed in fluid is equal to the weight displaced by the object. The first is the formula for buoyancy. P stands for air density, V stands for the ball's volume, and G is gravitational acceleration. A force of gravity is negative mass times gravitational acceleration. So the total force on the ball with both forces in account would be gravity minus buoyancy, which I found to be negative 9.67 meters per second squared. This is only a 0.1 difference from G. So the conclusion we can draw from this is that we can pretty much ignore the effect of buoyancy in practical terms, as it only accelerates the ball upwards by 0.1 meters per second squared. Thrust is the force that launches the ball upwards, generated by the player's jump and his extension of the arm. The concept underlying this is Newton's third law: every action has an equal and opposite reaction. When this player exerts a force onto the ground will exert the same amount of force back onto him, making him jump. Then the force will be transferred to the ball as a vertical force, giving it velocity. The more force the player applies to the ground, the more force will be applied to him, and thus more force will be applied to the ball. So, we've discussed the various forces acting upon the ball. Gravity pulls the ball down, drag pulls it back, Magnus effect pushes it diagonally, buoyancy pushes it up, and thrust pushes it up. We also know that some of these forces, such as gravity and thrust, have a large influence on the ball's trajectory, while others, like drag, Magnus, and buoyancy, don't have such a large influence. Now, with this understanding of the basic mechanics of the basketball shot, hopefully you will be able to apply it in real life situations, which is what I'll describe in the next videos. Thanks for watching.